Greetings. My name is Richard or Rick Lawford. I'm former senior scientist with Morgan State University in Baltimore. I'm going to speak today on Earth observations and the water-food connections in the basin of the Red River of the North. The Red River of the North, for those of you who are not familiar with it, is a transboundary basin moving water from the Dakotas in the U.S. through Manitoba to Lake Winnipeg. It has flat topography and extensive shallow flooding occurs during the spring as a result. Has clay soils that don't readily allow the infiltration of water. It has specific phenomena in the basin that lead to further water coming into the main stem of the Red. For example, Devil's Lake, this little area here, has extensive flooding in the spring and summer. And there is extensive use by farmers of the land drainage to get water off the land so they get cultivating earlier as in the spring. Information needed by agriculture includes information on the winter snowpack, which influences how much spring moisture there's going to be when the melt occurs. Also, during the summer, precipitation events can rise quickly and interrupt farm operations, and so the Global Precipitation Mission and its constellation of satellites is used to provide data for iMerge rain maps that farmers can use. Soil moisture is important for the plant growth. These data can be used to determine when to plant, when to cultivate, when to irrigate if needed. Available satellite data tend to be rather coarse at 25-kilometer resolution, but they are of some use when you want to find trends, aerial trends. Water resource management involves disaster preparedness. It also involves water quality monitoring and drought potential readiness. In terms of flood potential, it can be monitored by looking at snowpacks, high spring soil moisture, and rain on snow events. And water diversions and local land drainage are techniques that are used to overcome this problem. Water quality is monitored through in situ observations and are important because the farm fertilizer applications tend to bring nitrates and phosphates up to Lake Winnipeg. Drought potential has to be monitored as well. Drought begins when evapotranspiration is high and can be monitored quite accurately, and when rainfall is low, so that concepts can be implemented. In order to provide the information needed for the community, we're following a strategy of open science. We have to deal with things like the levels of authority for decision making in a basin which is transboundary, because the levels of authority vary from one basin, part of the basin, to the other. Canada is different than the US. Services provided and information services are not uniform across the basin. The federal government provides certain services in the US that the provincial government provides in Manitoba, in Canada. In situ observation density varies. North Dakota has a large mesoscale network, but the same is not true in Minnesota and Manitoba. So we're going to try and take advantage of the new open science policies that are being implemented. NASA is developing data sets that are going to be free and public in the near future. And open science is going to be promoted through the Group on Earth Observations, and we hope to have Earth products available. So our goal is to provide a information system for the basin based on the experience that has been realized in Spain, where there has been improved profitability and where there's been a lot of irrigation efficiencies derived, as shown here on this table. The technique would use a geo-knowledge hub to provide data into a platform, which then would disperse data and indices to farmers, both through registered users and broadcast to the public. So I thank you for your attention, and if you have any questions, suggestions, or collaborations to propose, they're all welcome, and contact me at rlawford@gmail.com.